Welcome back to channel, guys. Today is our ETABS class 6. So in the previous class we designed the model. Okay, so modeling part is done, and now we will see the loading part. Okay, so in today's session we will understand some concept as well. So first you see, uh, mainly our columns and beams and slab, which are made by the steel and concrete. So if you go in the interview, uh, they gonna ask why we use concrete and steel together in the construction. Okay, so you need to know that. So I will just explain you. If I would go Chrome, and I'm on the chat GPT right now, and I search on the chat GPT why concrete and steel both used together in the construction. Okay, so here you see it uses some point different strengths that fit together. Concrete is very strong in compression. As we know, concrete is very good in compression but weak in tension. Okay, so it cracks easily when pulled. And the compression member, as we know, the column is very good in the compression, but as compared to column, beams are the weak, because in the beams at the bottom side, beam has a tension and it can break. That's why we provide the steel in the beams. Okay, so concrete is good in compression but weak in tension. And here you see why steel, because steel is very good, very strong in tension and also good in compression. So steel is good in both compression and tension, but concrete is weak in tension. That's why we use steel in the concrete. Okay, and when combined, reinforced concrete can resist both compression and tension effectively. That's why we use concrete reinforcement in the concrete. Okay, and here are some options as well. Similar thermal expansion. Steel and concrete expand and contract at nearly same rate when temperature changes. Okay, good bonding, because we know the steel rebars have the lines pattern on it. That's why it can uh, make very good bond with the concrete. Okay, this bond ensures that loads are shared between concrete and steel. And it is also some point like protection for steel. As we know, concrete provides the protection for the steel from the corrosion, then cost and practicality, because steel is very expensive. Here you see, using only steel would be too expensive and not practical for large volumes. Uh, Here it given about the large volume, but if we are making small structure G plus one bungalow as well, it is very costly. By just by just make that building by using the steel, it is very expensive. We cannot afford that. That's why we need to use both concrete plus steel. Okay, so these are the some basic points, some important points, that why we use concrete and steel both together. Okay, now I will come to the my loading part. We will see the load coming on the floors. Mainly we see in this class for the loads on the floors. Okay, so we go to define. Here is option load patterns, and here you see dead and live already here. So what I will do, I will add floor finish plus ceiling plaster. Okay, that will come under my dead load, super dead load, and add new. Okay, so we will see the what kind of loads come on the floors. So I will open here. Here you see, here you see our loads on the floor loads. So self weight first will be self weight, because this slab have its own weight. Okay, this is a slab and slab has its own weight. Then the floor finish plus ceiling plaster. Here you see the top level of the floor finish on the slab. So that is also a load. That is also a dead load which is coming on this floor. And at the bottom side you see the ceiling plaster. That is also on this slab. So that is also a dead load which is coming on this floor. So floor finish plus same plaster. These both loads are coming on the slab. Okay, and third is your live load. Live load is also coming on the slab. Live load is nothing but the human beings and the furniture in that particular slab is coming on. Okay, so live load, floor finish plus ceiling plaster and self-weight of that slab. These three main loads will be coming on your floors. So if you want to calculate manually the slab load, so here you see thickness of the slab that is 125 mm. I am taking you can take 150 and whatever you want. So 125 mm. So you need to calculate the self-weight of that slab. So you need to convert into mm. So that will be your 125 into 25 is nothing but the unit weight of the RCC. Okay, you just need to multiply that and you will get the self weight of the concrete, self weight of that slab. Okay, and then you can add in that is floor finish load. Generally, we take 50 thickness because when you do the floor finish, that means there will be the mortar, and then we will put our tiles on that. So it's generally up to consider 50 So convert into meter point 0.05 into 20. Okay, 20 is its unit weight of that mortar. So generally it's take 1 kilonewton per meter square work in slope. Even if you check on the Google as well, here is the floor finish load as per IS course that is given 0.5 to 1.5 kilonewton per meter square. According to IS 875 part 1. Okay, and here you see typical values for types. Typical residential room live load is given here. Here you see the floor finish load 1.1 kilonewton is normally assumed, but this can be vary. This can be vary. I am telling you because according to materials and what kind of thickness of the mortar is coming on that. So according to that, it generally varies between 1 to 3 kilonewton per meter square. Okay, so you can take 1 kilonewton, you can take 1.5 or 2 kilonewton or 3 as well if there is more load on your floors. Okay, so floor finish load is varies between 1 to 3 kilonewton. Okay, uh, let's come to it tab. So here you see the floor finish load is calculated, and if there is a partition, okay, some are the office buildings, there may be partitions. So the partition load can be 1 kilonewton per meter square. So if you calculate the total load of this your slab, that will be 3.125 plus 1 and plus this one. So 5.125 will be your slab load, self weight of the slab load. Okay, but if there is no partition, like our residential building have the internal walls. So for the internal walls, we apply the different loads. That is your wall load. So in that case, you need to consider this 3.125 and your floor finish load. So dead load of this self weight of the slab will be 4.125. Okay, so this is how you can calculate the slab load, self weight of the slab load. And if you want to calculate the beam load, okay, what is the self weight of the beam? So you can calculate that. If you have the what kind of beam size you have, just consider into meter 0.225 into 0.400 into 25. 25 is nothing but the unit weight of the RCC. Okay, and to the calculations you will get the 2.25 kilonewton per meter load for the beam. And here you see the column load. Here you see the column size is 230 by 375. Just do the multiplication, and 3 is nothing but the height of the column. Okay, you need to for the column load you need to consider the height of the column, and then 25 is nothing but the unit weight of the RCC. So here you see 6.46 kilonewton. That will be your column self weight. And these three things always remember, guys. Here you see the slab load. Slab load is coming in kilonewton per meter square. Here you see kilonewton per meter square. And here you see the beam load is kilonewton per meter. Okay, slab load is coming under kilonewton per meter square, and beam load are kilonewton per meter. And here you see the column load is kilonewton. So these three things remember. Okay, now we will see for the live load. Okay, we see the self weight, we see the floor finish, the ceiling plaster, and now we will check for the live load. Before that, I'm just telling you, here we calculate the manually self weight of the slab. Uh, and here I show you just beam load and the column load, how to calculate the self weight. But we did not give this, we did not alternate showing this loads. मतलब हमने जो ये जो कैलकुलेट किया, ये जो मैन्युअली मैंने आपको दिखाया कि किस तरीके से कैलकुलेट करते हैं, लेकिन इटैब में हमें ये असाइन करने की जरूरत नहीं पड़ती, बिकॉज इटैब्स जो भी स्लैब का खुद का डेड लोड होता है वो खुद ही कैलकुलेट कर लेता है। यानी आपका जो भी स्लैब है, स्लैब का ये जो डेड लोड यहाँ तक आ रहा है, बाय द वी आर गिविंग एयर थिकनेस ऑफ द स्लैब। ओके, तो जो भी हमने थिकनेस दिया स्लैब का, वो इटैब्स खुद ही कैलकुलेट कर लेगा। ये 3.125 किलो न्यूटन पर मीटर स्क्वायर जो लोड आ रहा है हमें, वो इटैब खुद ही कैलकुलेट कर लेगा, हमें उसको देने की जरूरत नहीं है। ये जो बीम का लोड आ रहा है 2.25 किलो न्यूटन पर मीटर, जो भी हमारे बीम होंगे हमारे प्रोजेक्ट में, तो उसका जो भी लोड आएगा वो इटा खुद कैलकुलेट करता है। और सेम फॉर द कॉलम, कॉलम बीम एंड स्लैब का खुद का वेट इटैच खुद ही कैलकुलेट करता है। अभी आप बोलोगे कि कैसे कैलकुलेट करता है, सो आई जस्ट शो यू, बिकॉज वी ऑलरेडी डिफाइन द सेक्शन प्रॉपर्टीज हियर। फ्रेम section, here using the beam sizes and the column sizes we already given to the tabs, and here using define section properties. Slab section, we already defined our slab. We already given the all things, thickness and what kind of grade we are using, what kind of steel we are using. We all define here. That's why the column, beam, and the slab sizes we do not load. We do not need to assign. It has to calculate the self weight. Okay. So we हमें वही लोड अप्लाई करने पड़ते हैं जो हम हमारे यहाँ पे डिफाइन नहीं है। जैसे फ्लोर फिनिश का लोड हो गया, ये लोड खुद से लगाना पड़ेगा ई टैप को। ठीक है, और अगर कोई पार्टीशन आ रहा है तो हमें वो लगाना पड़ेगा, रिटेप को नहीं बताओ सारी चीज़ें। ओके, और लाइव लोड भी हमें लगाना पड़ेगा, रिटेप्स को बताना पड़ेगा कि हमें भाई हमारे बिल्डिंग पे 1 किलो न्यूटन लाइव लोड आ रहा है, और 2 किलो न्यूटन आ रहा है, या 3 किलो न्यूटन आ रहा है। तो हमें ये सारी बाकी जो चीज़ें हमें खुद से लगानी पड़ती है। ओके, सो यू अंडरस्टैंड नाउ सेल्फ वेट and floor finish ceiling plaster as well, and now we will check for the live load. So I just open the ISET 75 part 2 ISO, that is for my live load. Here you see ISET 75 part 2. You can download it from the Google as well. So I just open this code for the my live loads, and here you come on the page number 11. Okay, here you see sorry, here is the page number 7 actually on the ISO. So you need to come on the page number 7 of the ISO 75 part 2. And here you see input floor loads for the different occupancies. So from here you can see the what kind of the live load for the different buildings and different floors. So here is the residential building, all rooms and kitchens have the input load means the live load. Okay, that will be equal to kilonewton, and this is the uniform distributed load. And as I tell you, for the loads, the loads will be kilonewton per meter square. Okay, so for the residential building, all rooms and kitchens have the 2 kilonewton load. For the toilet, 2 corridor, passage, staircase, these are the 3 kilonewton load. For the balcony, also 3 kilonewton. And here is the for different rooms, how the different live loads. If you have designing the hotel boarding houses, lodging, so for that these are the different live loads. Okay, if you come here downside, here is the for the garages, we have the this kind of loads. For the educational building, we have the different kind of live loads for the different rooms. Okay, so from the by reading the dashboard, you can see that values and you can put in your project. Here for the institutional building, this kind of the live loads. Okay, so you need to read the IS code for that. IS 875 part 2 for the live load. And IS 875 here is you see IS 875 part 1 that is for dead load. And IS 75 part 2 that is for live load. Okay, so I will just come to the tab and go to define load pattern. Here I define the floor finish the ceiling cluster. Okay, so now I will add the live load, and from here I will select live, add new load. So here you see live load. Sorry, it is already defined actually. So I just delete it. Okay, so live load finish plus ceiling cluster and the self weight of the slab. These three loads are coming on my floor, and here you see dead multiplier is 1. So in that our slabs beams or columns are considered. ETABS will calculate that. We do not need to assign that loads. We just need to give live load and floor clean plus ceiling plaster for the floor. Okay, and now how I will show you how to assign this. Okay, I will just click here. Okay, and from here I will do all stories. I will go to sign, shell load, uniform. First I need to select the slabs actually. Okay, so what I will do, I will select the slabs. Go to assign. I will go here. Sorry, I will go to select object type, and from here I will select the floors and just select and close. Here you see all my floors are selected. So I am giving same floor finish load for all the structure. So I will go to assign shell load uniform. I will select floor finish plus ceiling plaster, and I will give the 1.5 kilonewton load for my slabs. Okay, and just apply and okay. Okay, and if you want to check the load is applied or not, I'm coming on the top floor. Yeah, here I am on plinth now. Now I am on the ground floor. So here you see the all loads are applied. Okay, and if you want to check in 3D, the option here, this special load assigns. From here you can see floor finish specific cluster apply. Okay, so here you see 1.5 kilonewton is load is applied to all your whole structure. That means on the all floors. Okay, now I want to apply the live loads. So what I will do, I will select the slabs again. Select, select object type, floors, select and close. So all floors are selected. I am assigning the same load on the whole structure. I will go to assign shell load uniform and I will select live load from here. Okay, and I will apply 2 kilonewton load for my whole structure. That's means on the each and every floor. Just apply and okay. Okay, so this is how we assign the all the floor loads. Self-weight is ETAB calculate itself. We do not need to add. We just apply the live load and we just apply the floor finish load. So these are the main loads are come on our floors. Okay, and where you will get the value of live load, you can read the IS at 75 part 2. Okay, from here you will understand what kind of load will come on different floors. Okay, you need to read the IS. So this is our today's class. I will end this class and stay tuned for the next video, guys.